basically when we talk about trees, how trees are made via recursion.
Yeah.
Okay, so trees are made via recursion. Okay, there is this thing when we talk about factorials. You remember in the video we had something like this. We were calling the factorial. You know factorials how they work out. It's like this one multiplied by let's say 5 factorial is 1 multiplied by 2 multiplied by, I'm just gonna use a dot, man, I'm so bad with asterisks.
Okay. Uh,
Okay, 1 multiplied by 2 multiplied by 3 multiplied by 4 5. Okay,
oh
so
yeah,
yeah,
yeah.
so that's how code is working for factorials. So
Right.
it's 2, then that's I think 6, 24, and 120. Okay, so
Right.
120. Okay, so now how do we process this via recursion? So when we're talking about recursion, we are sort of uh, multiplying the value before it. So it's like this. Hmm, it's return factorial n minus 1 and n minus 1. It's maybe like it's n multiplied by something, right? It's n multiplied by n minus 1, yeah, if I'm not
I
wrong.
think so. Yeah. Yeah.
N multiplied by n minus 1. Let me just erase it. Okay. So that's how it's working out. That's an asterisk. It's a terrible asterisk. I wish I could do better.
Try a different pen.
Uh, here you go. Okay, somewhat better. Okay, so now what it's doing is that this code, this line of code, this single line of code, okay, it has a
Right.
return statement, but
Mm-hmm.
over here, you might think that we kinda returned, okay, from the code,
Yeah.
but we actually did not. In my
Oh, okay.
in my we aren't returning from the code until or unless this thing gets resolved, okay, and this
Yeah.
thing this thing will take some time. Okay, so the thing is, in the last class we discussed on how the numbers are called in ascending or descending order. So we kind of make a stack. Okay, so when
Right.
we're talking about regular numbers, it's like let's say number printing in sequence recursion code maybe. Okay, it's just void sequence recursion code, gonna be something
Right.
like this, that we take a number, let's say int n maybe, and if you want to print them in descending order, then we could just see out n. Okay, space
Mm-hmm.
of course. So this not a c out, I'm so sorry, it's a system dot c
Oh.
plus plus system dot out dot println. Oh my goodness, I was in c plus plus. Okay, okay, great. So okay, and now we printed it, and we moved the line, okay, as well, so it's 5, and then we're
Mm-hmm.
gonna just call sequence strict again, but we're gonna call it with something like n minus 1. Okay, and after it we're gonna say return. Okay,
Yeah.
great. Now what is missing over here? Can you tell me what's missing over here?
A semicolon next to return.
Yeah, that is missing. That is something you identified, but what else? Not a syntax error. Tell me something else. Where do you identify the syntax error? But there's something else missing. Just tell me, what is this called? We discussed it in the last class. What is this called? using this line. It's called something. Maybe like something like a general. You
This
remember?
is not a constructor, if I'm not wrong. Is
No,
it?
it's not a constructor. It's calling the same function. What did we call that line which called the same function?
Something recurring. Hold on, let me think, let me think. Is it a recursive call?
Yeah, it's a recursive call. It's called a general case as well. Which we discussed.
Ah,
There
okay,
was
okay.
a base case and there was a general case. So tell me, what's the
Oh,
base case
yes, yes.
and where's the general case? Have I written the general case? Oh, sorry, have I written the base case?
I don't think so.
Yeah, I didn't write the base case. Okay, so in this piece of code, okay, we don't have the base case. So what it's gonna do is it's gonna never stop printing. Okay, so it's gonna
Right.
be let's say n is 5, so it's gonna be 5 4 3 2 1 0 -1 -2 -3 and so on till infinity. Okay, so this code is gonna
Right.
be like over here, then it's gonna be over here, then it's gonna go over here, then it's gonna go over here. Okay, so and your stack will overflow at some time. You remember how the stack got built up? You remember that,
Yeah.
right? It was like something like this. First, we couldn't complete
Yes.
our code for sequence n. Okay, so since we didn't return from it, so we pushed that onto the stack. Okay, sequence rec and then we visited n minus 1. We couldn't finish it, so we pushed that up as well. Okay, sequence rec n minus 1. Okay, so let's say it kind of ends on 0. Okay, so
Yeah.
we're just gonna write a statement if uh, n equals to 0, then return. All right.
Yeah.
So now what's going to do is that when this call will be 0, it won't print 0, it will return, and when it will return, it will come over here and it will end the sequence check for 1 as well. Okay, so this is currently, let's say this is 1, this is the sequence for 1 running. Okay, it calls the sequence check for 0. Okay, n
Yeah.
is 1. Okay, let's suppose over here n is 1, so it prints the 1, then it calls it for 0. Okay, because it's n minus 1, right?
Right.
So when it calls it for 0, it reaches the base case returns, we come back over here, it doesn't resolve to anything, it doesn't output anything, and we return from the 1 as well. Okay,
Right.
then n equals to 1. Cool. Okay, so now just for a recap, when we take this system out of println line and we bring it down after the return, how does that have a different effect? Just for a recap.
So when you swap them around, the order in which the code is executed also changes. So right now, if you are um, doing, if you're using calling the function first and
Mm,
then printing it, it will print out the affected number.
mm,
And if you were to swap it around in a way that it would print the number first,
mm,
then it would like call the function. So it's printing the unaffected number first and then the calling the function.
mm. That's
So like
great.
swapping them out basically does the reverse of what they're intended to do.
Mm, great. So you can visualize it via the stack. Let's say we're calling it
Hmm.
for 1. So no, let's say 2. Okay, so we're calling it for 2.
Okay.
So what happens is that it doesn't get to finish the program, the first function. Okay, the one for the 2. So it kind of pushes it onto the stack by the return statement over here. Okay,
Yeah.
so it sort of pushes it onto the stack. So it's like push sequence back to nothing got printed as of yet, since the system dot out dot println statement is over here, the return statement is over here, and before finishing our sequence rec 2, we called sequence rec n minus 1, which is 2 minus 1. We called it for 1, and now 1 couldn't get finished. Okay, One can
Yeah.
get finished. Since two statements were remaining, you can put as many statements as you want below it. Okay, which one in
Right.
reverse. So it didn't get to finish, and we sort of ended it with pushing it onto the stack. Didn't end it.
Mm-hmm.
We This is the one. We just push it onto the stack to do it later.
Right.
Now, when we are pushing one onto the stack, we didn't get to complete one. We called sequence x 0. Okay,
Mm-hmm.
so we called sequence x 0 over here, and now we're sequence x 0. We reach the base case. We return from it. We return from it to where? We return from it to sequence x 1 over here at this line,
Right.
this new line. Okay. Now we return to this new line, system.out.println, and over here it was the value of n was 1. Okay, so it printed the 1, and then we returned from it. Fair enough.
Yeah.
We returned from it, and then we when we returned from it, we came to the line over here for sequence rect 2. Okay, over here.
Mm-hmm.
Okay, this new line, since this got executed, got it, so we came to this new line.
Yeah.
So now we printed 2. So the order in which it got printed is 1 2 on the console. Okay,
Right.
you've seen the code already. Now we're gonna discuss the factorial, then we're gonna discuss the Fibonacci once more, and I'm gonna tell you how the trees are built. Okay, that is really fun. How the trees are built, and
All
the
right.
and the paths as well. We're gonna do the paths. It's gonna be a long class. Okay,
Mm-hmm.
okay. So it's gonna be a fun long class. So
All right.
okay, so when we talk about factorial, okay, it's n multiplied by factorial n minus 1. Okay, so this is the
Yeah.
factorial is the function name over here. So it's gonna be something like hmm, gonna be something like int, since it's a factorial. Okay, and
Right.
it's gonna be something like if this is the base case. By the way, when we're writing the if statement, it's probably the base case. We're gonna leave it for now. We're gonna think about the base case for later. Okay.
Okay.
So what we're gonna do right now, right now is just put the return, maybe depending what can we put it over here. We're gonna figure out the return statement as well later. Okay. So
Yeah.
right now, what we're gonna do is we're gonna write our general case, and we're gonna understand our general case. So how is our general case working? Our general case is n multiplied by factorial n minus 1, right?
Mm-hmm.
How does this work out? How does this you know relate to the factorials? Let's say we have called factorial for int n. Okay,
Right.
now we've called it for int n. Let's say it's 5. Let's say n is 5. So our if statement, let's say it's for something less than 5. Okay, we're not gonna discuss what it is for. We to make our function run, we need it to be something different than 5. Okay, less than 5 probably.
Right.
So we're gonna just say n, which is 5, multiplied by factorial n minus 1, which is factorial 4, right?
Right. Yeah.
Okay. And yeah, so what it's gonna do is it's gonna go up with a value of 4 now. Okay, and it's
Mm-hmm.
gonna stay. This 5 multiplied by, it's gonna stay over here. This is gonna get resolved. Okay, this part is going to get
Yeah.
resolved. So we're gonna do it for a 4. Now when we go up and we do it for a 4, it's the value of n is 4 now. Okay, so what it
Right.
does it gets to the same line, but this time the value of n is 4, and this gets to 3. You get it?
Mm-hmm.
So right now, when you're talking about recursion, it's like something like this: 5 multiplied by factorial uh 4. Okay,
Yeah.
so and then that factorial 4 kind of resolves into 5 multiplied by 4 multiplied by factorial 3. You get it?
Yeah.
And then the 3 resolves into 5 multiplied by 4 multiplied by 3 multiplied by factorial 2. Are you getting that?
Yeah.
Okay, so that's the pattern. Okay, so that kind of ends up. Now when do we end it? Do you know when should we end it? At which base case value of n?
When n is 0,
Yeah, since 0 factorial is 1. What about 1 factorial?
1 factorial is also 1.
Yeah, 1 factorial is also 1. You're a genius in maths as well.
Yeah.
Okay,
Thank you, thank you.
so it's gonna be something like yeah, it's gonna be something like this. It's gonna be n equals to 1 or n equals to 0. Okay, it's gonna say 1
Right,
and
okay.
it's gonna return. So now what's gonna happen is that when we reach factorial 1, okay, it's gonna say, okay,
Yeah.
you've got it to factorial 1. So if they call it, we use the 0 by the way, for the point when they call it for a 0. Okay, so it should work for 0. That's only why we added a 0. Otherwise, it's gonna work for all numbers except the value of n equals to 0. You get it? Since
Mm-hmm.
we reach 1, we never reach 0 from any number that's above 1. Okay, or above
Yeah.
or above 0. Oh, sorry, above 0, above 1 doesn't matter. So it reaches 1 first, then it reaches 0. So it never gets to reach 0 except when we call it for 0. You get it?
Right, yeah.
Yeah. So what's happening over here is that we called it, it's doing this thing, but we haven't put a return statement. It's resolving this line, but that line is going nowhere. Okay? It doesn't
Yeah.
place it somewhere, it doesn't place it in a result kind of a thingy variable, it doesn't return, it doesn't do anything. You get it?
Mm-hmm. Yeah.
So what should we do? Our function returns an integer. Should we use a variable? Would a variable work out?
I think it would, yes.
Okay. So a variable, let me think. A variable should work out, honestly.
Right, yes. I
Hmm.
think it would as well.
A variable should definitely work out. Something like result, okay? Maybe int result and place it over here and then return result, right?
Yeah.
Right? Hmm.
Uh-huh. Yeah.
Hmm. Hmm. But let me just think for 1 second. Since your question is kind of hard, it's kind of fun as well.
Hmm. It is,
No,
yes.
no, no. It's not. It's gonna be like result, result. Okay. We'll just say we declared somewhere int result equals to 0, and we're gonna say return result. Okay, let's think about this code for a second before we say that it's
Okay.
right. Okay.
Okay.
So what it does is that for the factorials, it sets results to 0. Okay. It checks whether
Yeah.
the value of n is 1 or 0. It isn't. Let's say it's 4 at the moment. Okay. Let's just say
Mm-hmm.
it's 4. Okay. When it's
Right.
4 and the starting value of n is 4, and what we do is we do a 4 multiplied by factorial n minus 1, and we place it in the result. So this has to get resolved. This is factorial 3. Since it's n minus 1, it's 3. Okay. So 4
Right.
multiplied by factorial 3. Then we go up and we do it for 3. Result is again set to 0. Okay. And
Yeah.
we do it. We check. It isn't what it should be. And the factorial is called again. It's called for 2 multiplied by factorial and minus 1. And so on until it gets to 1. Okay. So
Uh-huh.
it gets to 1 and the value of the factorial is returned. Now it's returned on each result. Okay, it gets returned
Right.
on the result for, yeah, it gets returned for the result. So everyone gets the result, it places the result. So it's
Uh-huh.
something like the result has actually no value when we return from a function. the only the result is something that should matter, but it does not. It doesn't get used over here. You get it?
Yes. Yeah.
Okay, so the result is getting changed. It's not getting used. Hmm. Should we run this and check this?
I think we should. Yes.
Yeah. Okay. So I'm just gonna write program is and Java. Program is Java. So I'm gonna make a function for public static
Mhm.
int factorial int n. Okay, and then what we're gonna do is a if statement n equals to 0, n equals to 1. We're gonna return 1 in this case. Then we're gonna say okay. Now we're done with that. Let's just call it for factorial n minus 1 multiplied by n. Gonna have an int result which is 0. The thing is, it should like result should get changed each time. Return
Yeah.
result. So, and then we're gonna just call it over here for 5. Let's say system dot out dot print out or print ln. No, wait. Yeah, it should work. Factorial. Factorial. Let's say 5. Let's see what it gives us as a result. Then we're gonna think about it. It's giving the correct result. 120. So that's great. It works, but we're still gonna try run it. Okay?
Yeah.
So what's happening over here? Why does this code run? Aren't we setting the result to 0?
Yes, we are. Yeah.
Another thing is
So
that
that would be our initial, I guess, number.
hmm, yeah, it does not matter what the value of result is. It does not even matter if we do a return result like this. It just needs to happen
Yeah.
for the last statement. Otherwise, it can be returned anything for if. But we just do it since we have to return result for the very first function call factorial 4. Okay, which was a starting function call.
Mhm.
Okay, let's say factorial 5 was a starting function call. Okay, scratch that. Factorial 5 was a
Right.
starting function call, and let's just say that we only need to return the result for factorial 5. We do it for every other kind of you know function call. We return for 3, return for 2, and what that gives us is that it stores the value, which is let's say let's say 3 multiplied by 2, let's say. Okay, factorial 2. Okay, so let's say
Mhm.
this gets to resolve into 6, and that 6 gets stored in result. Fair enough. So return
Yeah.
6 from the result. Now this returns 6, okay, which is then result. That gets over here, okay, and this is our 4, okay. So 4 multiplied by 6 is 24. That gets stored in result, return result. So that's 24. 24 over here multiplied by 5 over here. That is also to 120, and that gets stored into result, and that is returned in the final result. You get it?
Right.
Okay. So we can do it like that. That works. You've seen it. I'm just gonna check it before. I was like, if I teach it and then it ends up being wrong, okay.
Mm.
So since we
Yeah.
kind of make mistakes at times, so I just
Uh-huh.
wanted to be sure about it before we did it. Okay, so what we can do as well is that rather than using a variable, we can just return. Okay, we can just
Yeah.
return directly. We don't need a variable. We're gonna say okay, return n multiplied by factorial n minus one. So now it's gonna go to the return statement. It's gonna say, all right, I'm over here. I'm the return statement. I'm gonna do an n multiplied by factorial n minus one, and yeah, I'm gonna do a 5 multiplied by factorial 4. That's gonna resolve into a 4 multiplied by factorial 3, and from that there's gonna be a factorial 3 multiplied by factorial 2, and so it's gonna go on and on till 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by factorial 1. All right.
Yeah. All
That
right.
factorial 1 is going to resolve into 1. So it's going to be a 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay. So that's going to be a 120. That's going to get returned. Since the final return statement got resolved, okay, the previous return statements ended up giving the value over here. The final return statement ended up giving the value in the main in the system dot system dot out dot println statement. Fair enough?
Fair enough.
You get it?
All right. Yes.
Yeah, this is something I'm very passionate about. This is something like which
I can see that. Yeah.
yeah, yeah. Am I going too fast?
No, no, you're fine.
Okay, great. So we've discussed factorials. We haven't discussed how trees are built. That is something fun. This is not like fun. It is still like calling something like this. It's still doing something like this. It's doing it like okay. We have R5. Then we're gonna go to 4. You saw the visualization in my video on
Indeed, I do.
yeah.
Yes.
So
And then
then it
three
goes
down, two, and then one.
yeah. So
Uh-huh.
it kind of goes from function call to function call, but it goes like this. You get it?
Right.
It
Yeah.
doesn't go like this and this, and then this and this and this and this and this and you get it? It's not going like this
Hmm.
right now. Okay? And this is where trees come in. You get it? Trees
Yeah.
they come in at this point, and this is the fun point. How does this work out? Let's talk about a different code. Let's talk about the Fibonacci sequence. Okay? The
Yeah.
Fibonacci sequence. Okay, so let's say a Fibonacci sequence. What is the Fibonacci sequence return? What does it return? How does it work? Do you remember what a Fibonacci sequence does or returns?
Oh no, it was a long time ago. I need a refresher, a very slight refresher.
I you didn't see the video?
No, the last time we did this was in my ninth grade, O level.
But think about it. Think hard. How does it work? How does it work? Maybe a 0 plus 1 equals a 1. Maybe a 1 plus 1 plus 1 equals to a 2. Maybe
Ah, yes.
maybe 2 plus
And
1
then a
equals to
two
a
plus
3. Am I
is
right?
a six, so a five, and then a five plus
So Fibonacci sequence works like this. It's n,
uh,
an minus 1 plus an minus 2. Okay, that's a Fibonacci sequence. It's like
okay.
multiply the previous term and the one before it. Okay,
Yeah.
and you get the current value, and then use it as the previous value for something else until you get to the real n. It's like you get it?
Right. Yeah.
So now, where do we start a Fibonacci sequence?
We started at zero,
You
if I
start at
recall.
0, most definitely. We start at 0, and the answer for 0 is 0. The answer
Yeah.
for 0 plus 1 is 1. Answer for 0 is 0. But over here, the base case is really important. Okay, the base case is like so crucial. I'm gonna just write a code for you. It's gonna be like in
Mm.
Fibonacci. Okay, it's gonna be like and and
uh,
then we're gonna leave this statement for now. We're gonna figure it out later, but it's gonna be something around 0 or 1. Okay, I just wanna add a puzzle
okay.
in this for you. Okay, I want you to figure it out, and then we're gonna discuss how it's working. Okay, so we're gonna have just as you said an end result, right? That equals to
Yeah.
0, and we're gonna have a final value. We're gonna have a result, equals to our value, which is n, multiplied by Fibonacci. Okay, and it's gonna be, no, it's, oh, I'm so sorry, I went into factorial mode.
Oh boy.
So it's gonna be something like this. This, by the way, this result, let's call it our, I'm just gonna rename it to an. Okay,
Mhm.
or yeah, I'm gonna rename it to an. An. You know, to give it an effect of an an. Okay, so this is an, and what we have over here is we have our previous two terms. Okay, so we have our previous two
Yeah,
terms, and we have our an. Okay, so how do we get to our previous
right.
two terms? We do it like this. Fibonacci n minus 1 multiplied by Fibonacci multiplied नहीं plus होगा Fibonacci n minus 2. Okay, so great.
Hmm.
Mm-hmm.
Yep.
I'm gonna just say return an, problem solved. Okay, let's think about this for a second. Okay, let's just think about it.
Yeah,
Is this right?
I think it is. Yes.
Okay, so let's say we have a number like 5 to write the Fibonacci sequence until 5. Okay,
Hmm.
so what we're gonna do is we're gonna say, okay, Fibonacci sequence should run until 5. It should run for 5 sequences, I think. Yeah, it should run for like 5 sequences. It's gonna start from a 0 plus 1. It's gonna be a 1, that's the first one. Okay, let's call it the first one. It's gonna be
Yeah.
the second one. It's gonna be the third one. Fourth, let's say it's 4. Let's say it's 4 sequences. Okay, I don't have the space for 5 right now. So yeah,
Uh,
it's gonna be like this. This is gonna be, by the way, it's gonna
uh,
be like, this is gonna be the an minus 1 term, and this is gonna be the an minus 2 term. Okay. So now what we're
okay.
gonna have is we're gonna have a 1 at an, and it's gonna be like this. This is gonna be this value, and this is gonna be the previous one. Okay.
Yep.
Okay. So it's gonna be like this becomes the previous, and this becomes the previous to the previous. You get it?
Oh, okay. Okay.
But we
Yeah.
don't
Yeah.
take the one which is previous to the previous to the previous, which is this. We ignore that for the next round. Okay.
So the
So
third most previous value is ignored.
yeah,
Just the first two previous values are taken.
of course. So what's gonna happen over here is that now this value is gonna be taken and this value is gonna be taken. It's gonna be a 2 plus 1.
Right.
Okay, and this is
Okay.
gonna be a 3 for the third statement. And then we're gonna have a 3 plus 2, which is gonna be a 5. And a 5 should be returned for our n4. How much battery do I
Hmm.
have? I have 32%, 30%. Damn, that's low. Anyways, we can still make it through. Push through 5. Uh-huh. So we have our code. How does our code work? That's the fun part. That is so fun, you're gonna get blown away. You're literally gonna
Oh
get
boy.
blown away. But first we need to figure out what's gonna be our if statement. What is gonna be the value of n for which it says, alright, we've reached our base case, we've reached our value, and now we're gonna just say stop. Can you figure it out? I'm gonna give you a hint. It's actually
Okay.
two if statements. It's not one. Two if statements with
Oh,
two different return values.
so a nested if statement.
No, no, no. It's like this.
Oh, they're separate.
Two
I see.
conditions with their own returns. Okay. So this has a different return value and this has a different return value. So fill in the blanks are these, the blue ones. This, this, and this. And then we have our, you have to fill in the blanks. Okay.
Hmm.
So we're
And
gonna
what are we looking for exactly again?
we're looking for Fibonacci sequence, and I'm just gonna tell you that we think of it like from the very start when we're talking about the base cases. So for the last one we had factorials, so we thought about the very first factorials that existed, which were 0 factorial and 1 factorial, right?
Oh,
Sorry,
yes.
1 factorial. So over here, where does the Fibonacci sequence start from?
Zero.
Yeah, it starts from a zero. That's great. So what should be our base case? One of our base cases. N equals to
n equals to 0,
great. And what should we return when n equals to zero?
n plus 1.
Hmm. I should return n plus one. Should return something else. Okay, tell me about this one. What could be the value for this one?
If it's 1 factorial, so then n equals 1.
Oh, one Fibonacci is yeah. So yeah, it's gonna be n equals to one. That's right.
Oh, yes.
Both of these are
Yeah.
right.
Mhm.
Okay, but the return statements,
Oh,
they are crucial. Just think about it.
mm,
If we
yeah.
call a Fibonacci for zero, what's gonna be the answer?
0 plus 0 is 0.
It's gonna be a zero, but your understanding of it is a bit off. We start from a zero. Okay, we start from a
Yeah.
zero, and we're talking about a zero. We start from it, and we kind of don't go anywhere. Okay, we don't have any steps.
Hmm.
We don't have any moves. Let's say we don't have any moves. Okay, for
Yeah.
let's say we had four steps, we had four moves over here, and that resulted in our value of 5. Okay, it's kind of like
Hmm.
computing a value. Okay, it's 5 for 4 steps. Maybe if it's 6, it's gonna be a different value. Okay, 6 steps. If it's 0 steps, then what is it gonna do? It's gonna do nothing. It's gonna just say 0. Okay, but
Yeah.
for this one, n equals to 0, it's gonna do something, because since we have one step, you get it,
Hmm.
we have one step available for over here. We have one step available.
Right.
It's gonna be something like this. It's very difficult, so that's why I'm doing it for you. It's gonna be
Okay.
something like this. Either you can return a 1, okay, which is simpler, but just for your understanding, I'm just gonna write it like this. It's gonna be a 1 multiplied by Fibonacci. I'm so sorry, 1 plus Fibonacci, uh, 0. Okay,
Hmm.
it's gonna be like this. And Fibonacci is equal to 0, so it resolves to a 1. Okay, so these are your two base cases. Okay, a 0 and a 1,
Yeah.
or a 0 and a 1. Now, why did we need two of these? Because when we're, let's suppose, talking about n equals to 2, okay, what we're gonna have here over here is that we're gonna have n minus 1, which is 1, and we're gonna have n minus 2, which is gonna be 0. Okay, we're gonna have a
Hmm.
fib 1 and a fib 0. Now, let's suppose we talk about a fib 1, okay? If we are talking about a fib 1 and we don't have this statement, let's just ignore this statement for a while. Let's say this does not exist. Then what it's gonna do is they're gonna say, all right, we didn't reach the base case. Okay,
Hmm.
we didn't reach the base case. We went over here, and then what it's gonna call is it's gonna call an n minus 1, which is 1 minus 1. It's gonna call a 0 over here, and it's gonna call is a 1 minus 2, which is a minus 1. We don't have a Fibonacci for minus 1. You get it?
Yeah.
So that's the problem. We have to identify both these cases. Okay, we have to identify a case for when n can be 1 or n can be 2. Okay,
Hmm.
over here, since it won't work otherwise. It won't
Yeah.
work otherwise, since we have an n minus 2 and an n minus 1, and n cannot be less than 0. It can be 0, it cannot be less than 0. So to cover for that, we have to add the values for both n equals to 1 and n equals to 0, which are both cases, which are both values. Okay,
Yeah.
where we can kind of go into the negative realm. Okay, for n equals to 0 and n equals to 1, we can go into the negative realm if we execute this line. So we kind of just avoid these, and we return something. We return something that should be returned, which is 1 or 0, depending upon the case. Fair enough?
Right. Yeah.
So should I write it down in the code? Right, I'm just gonna write it down. Okay. So we
Okay.
have public static int Fibonacci maybe I got the steps a bit wrong. Like, let's say it's gonna run for, it's gonna be a bit different the steps, but the logic is the same. Okay, wait, this is that. Okay, this is good. Int n equals to 0. If n equals to 0, then we're gonna say return 0. If n equals to 1, then I'm just gonna go, you're gonna say return 1. And okay, so it's gonna be an equals to Fibonacci n minus 1 plus x plus, okay, plus Fibonacci n minus 2. Okay. And we're gonna just say return n, and we're gonna run it. No, we're not gonna run it yet. We're gonna just change it a bit over here. We're just gonna say, rather than putting a pictorial and Fibonacci.
Uh,
Now, I hope it's right. It's gonna be different value if it's right. It's gonna print an error if it's wrong. Okay, it's 5. Okay, that's great. But let's just okay, let me explain why it's a 5 and why it's not a 5 for 4, as we discussed over here. Why it's a 5, okay, for the value
mhm.
5. Okay, so what's it doing over here? It's kind of like skipping a step. Okay, so what we do over here is that when we call Fibonacci for 2, okay, so what it does is it calls it for fib 1 plus fib 0, right? Right?
Yeah,
So
yeah.
what's happening over here is that this was supposed to be n equals to 2, right? Since fib 1, fib 0, right?
Mhm.
Okay, and then the counting follows 3, 4, 5. Okay, and this is supposed to be, which is 1, okay, which is one of our base cases, and 0, which is our another base case. Okay, so that's how the
Right.
code is working actually. So if we change this value and we change it to something else, maybe we're going to change it to something else. So let's say we're just going to change it to 7,
Yeah.
and now it's going to print something different. It's going to print 13. How is it 13? Let's just figure that out. So for the sixth step, we have our 5 over here, our 3 over here. So 5 plus 3 equals to 8. And seventh step, we have 8 over here, 5 over here. 8 plus 5 is what? 13. You get it?
Yeah.
Okay. So that's our Fibonacci, but it's not done yet since we haven't understood trees yet. Trees are trees
Mhm.
are gonna be so fun. You're gonna be blown away. Okay.
All right.
Okay. So the statement. This is where the fun starts. Return. Okay, let's say we're just gonna talk about it. We can write return or we can write an. Okay, whatever's your choice, and we're gonna just write return an. Okay, it's up to you.
Okay.
Okay, you can just write one line which is return, and then you can write the whole thing over here for it, or you can just do it like this. It's up to you. Okay, so we're just gonna say fib, and we're gonna say n minus 1 plus fib n minus 2. Okay, so this is our general case, and this is where the fun starts. Let's say we call it for 5. Okay, maybe let's say we call it for, let's say we call it for 5. Okay, so we call it for n on the value of n of 5. So how does it look like on the stack? Let's figure it out first on the stack. Fair enough?
Yeah.
So stack looks like something like this. It's, it comes to this word, okay? And it's like, oh shoot, I have to push fib n onto the stack since I cannot finish it
Mm,
yet.
yeah.
Okay?
Right.
Okay? And it's gonna run this one, which is fib 4. Okay? It hasn't even reached this one yet. Okay,
Yeah.
it is gonna run fib4. It will completely ignore the n minus 2, which is fib3. It's gonna just run fib4, and this is gonna end up being part of the stack as well, as fib4 is uh is nothing but a recursive call itself. So it's gonna be n minus 1. I'm just gonna show you the code since it gets a bit tricky. Okay, so where is the code?
Yep.
Where's the code? So yeah, So we again move into the code for fib4, and we kind of get over here, and then we say, all right, we've read this statement, which is fib3. We don't even check this statement, okay, which is fib2. Okay, we just
Right.
read fib3 from fib4, and we push and we go for fib3 now. Okay, we don't even care about we don't even care about fib4 anymore. Let's just say 5, and then we're going to say 4. Okay,
Uh,
clarity 5 4, and then we go in the same way for fib3. Okay, and then fib2, right? You getting the whole thing?
yep.
And then it's fib1. No, fib1 doesn't go in, sorry. Fib1 is our base case. So what happens in a fib2 is that we reach our base case finally, okay, which is fib1, since 2 n minus 1 2 minus 1 is 1. Okay, so we kind of reach our base case for this one, and then we execute this one, which is Fibonacci n minus 2, which is 2 minus 2, which is 0, and we reach the base case for this as well. So finally our fib2 returns, what does it return? It returns a 1, right? 1 plus
Yeah.
0 is a 1. So our second uh, value of n, like over here as we discussed, returns a 1. Okay, so yeah, so fib2 returns a 1. Great, so we take it off the stack, and now we are at fib3, right?
Right.
We are at fib3 since we completed our fib2. We are at fib3, and where exactly are we at fib3? We are exactly at this point. Okay, we've executed
Yeah.
this line, fib2 and minus 1, right?
Mm-hmm.
We are in fib3. Okay, and we just executed this one, fib2. We just resolved it. We resolved it to 1. Okay,
Okay.
and now we are over here. We're just gonna say plus, and then we're gonna read this, which is Fibonacci 3 minus 2, which is fib1, and this gets resolved to 1. Okay, so it's 1
Yeah.
plus 1, right? 1 plus 1. Fair enough. So fib3 is resolved now. It's 1 plus 1, right?
Yeah.
Fib3 is resolved. It's 1 plus 1. It returns that value to our fib4. Okay, so we are now in our fib4. It returns our value for fib3 over here, right? And what does it
Uh-huh.
return? It returns a 1 plus 1, right? Since our
Mm-hmm.
fib2 since our fib2 was 1. Okay, our fib2 was our fib1 plus fib0, and our fib1 was already a 1, so our fib3 returned us a 2, right? You can check that
Yeah.
out over here, right here. Okay,
Mm-hmm.
so fib3 returned us a 2, and
Right.
but we still have fib2 to go. Okay,
Okay.
so what are we gonna do over here? We're gonna push our fib. We couldn't complete our fib4, right? So it stays onto the
Yeah.
stack. Okay, it isn't pushed actually, it just stays onto the stack, and we go in our fib2, right? Now as you
Right.
remember, fib2 wasn't able to finish as well, right? So fib2
Yeah.
is pushed onto the stack, and then we visit fib1. Okay, fib1 gets resolved into 1. Okay, since it's n
Yeah.
minus 1, fib1 gets resolved, and then plus fib0, and fib0 also gets resolved, right? So it's 1.
Yeah.
So fib2 again returns 1, so this gets erased, and our value is right now fib3 had 2. Okay, which was resolved by fib4, right? The line at
Yeah.
fib4, and fib2 resolved into 1, right? So it's a 2 plus a 1, right? So fib4
Uh-huh.
returns a 3. Fair enough.
Yep.
Fib4 returns a 3, and we take it off the stack. Okay, so now we are at fib5. Now our fib5 is something different. Uh, we are left with a fib5, and our fib5 has successfully resolved fib4, right? What was the value of fib4?
Yep.
It was 3, right?
Yep.
So it has successfully resolved fib4, which is 3. But aren't we left with something else? Maybe a fib3, right? We're left with a
I think
fib3.
so, yeah.
Yeah, since that part didn't get executed yet. That part is left. So what it's gonna do is it's gonna push a fib3, and then the whole thing, like a fib3 pushes a fib2, and then a fib2 gets resolved, right? It resolves into a 1, and that goes into a fib3. Now it goes into fib3, and fib3 calls fib2 plus fib1, right? So fib2 is 1, and fib1 is already 1 as a base case, so we have a 1 plus 1 equals to 2 for our fib3, and that returns us a 2, right?
Yeah,
Okay, so that is a 2. So our fib3 returns us a 2, and our fib4 already has returned us a 3. So now our final answer is a 5, right? For
right.
fib5, and fib5 is taken off the stack, and that is it. And that is something which is consistent with our result over here. Okay, so fib5 is taken off the stack, and that is something which is consistent with our this statement, right? This one. Okay, fair enough.
Yeah.
How much
Mm-hmm.
charging do I have? Like, come charging. Okay, so we're just gonna
Hmm.
wrap this up. Wrap
Okay.
it with trees, with the understanding of trees. Now, how is it working out? We're gonna do paths in the next class, okay? Since we don't have
Okay.
anything else to do, we're doing recursion, and we're gonna do paths in the next class. How to find paths, and how to get to a goal, like from an array. Let's say we have an array, like we have a start point, okay, at 0 0,
Yeah.
2D array, and then we have just like we can move in the pluses, or maybe something else. Maybe we can move in the ones, and we can't move in the zeros, so it's gonna be like something like this. And we have 1 1 1 0 1 1 1 0 0 1 1, and our goal is over here, okay? So it's gonna
Mm-hmm.
be 0 0 1, okay? So it's gonna be something like this. And what's that recursion going to do is it's gonna explore all the possible paths, and then it's gonna come back. So it's gonna be like, okay, I checked it out, and I can find a path over here and over here, and now I can't find any path. Since the right side is nothing, the left side is a 0, can't go in a 0, it can't go over here, it can only move it like this, okay?
Yeah.
Okay, it can only move in these directions. So it doesn't have, so the only way it has now is to go back, and now it checks over here. Do I have a move over here? Do I have a move over here? Do I have a move over here? And I've checked this one, okay? So it's not gonna go over here again. So what it's gonna do is gonna go over here, since it only has a move over here, and then it's gonna say, okay, do I have a move over here? Do I have a move over here? I can't go over here since I visited this, right?
Yeah.
So it goes back then, and then from over here it says, okay, do I have a move over here? Yeah, I do. Okay, do I have a move over here? Yeah, I have a move over here, but I don't have a move over here or a move over here, and I visited this. Okay, uh, maybe like this, and then it's gonna say, all right, I don't have a move over here. I'm gonna just go back, and then it's gonna say, okay, I have a move over here. I have a move over here. I have a move over here, something like that. It's gonna check all the possible moves, and it's gonna say, okay, I have a move over here, and then it's gonna reach its goal like this. Okay,
Uh-huh.
you get it?
Yeah.
So that's our next class. Just a gist. Okay, so we were doing trees. So how does our trees work over here? So it's like, let's call fib5. Okay. So what it does is
Mm-hmm.
it calls our fib4 and our fib3, right? So what we do is we kind of start the recursion for fib4. Okay, just like a linear
Yeah.
recursion. I'm just writing it in a way which is somewhat diagonal. Let's just say I'm writing linear recursion, like the one in the factorial one. You remember that, right? It was like n
Yeah.
multiplied by, like, 5 multiplied by fib4, fib4 multiplied by fib3, and all. Okay, but I'm just gonna write it like diagonally for now. Okay, so it's fib4, then it's at 4, and then it's gonna say, let's say I'm gonna call fib3, right?
Mm.
It's
Yeah.
gonna be fib3, and then that's gonna call fib2. Okay, just gonna, yeah, fib2. Why did I write fib2? I just write and 2 and fib2. Gonna stay consistent,
Mm.
and then that resolves into a fib 1 and a fib 0, which are the base cases, right?
Yeah.
They return 1 and a 0, so a 1 plus a 0 is returned. Okay, so it's a plus, so that value is returned over here. So now it has a value of 1. Okay, so
Right.
now what happens over here is that this still has a statement left, right? So it has a
Yeah.
statement which is fib1, which is left. Okay, so I'm just gonna say fib1, and fib1 gives us a 1, right? So it's gonna be a 1. Fib2 gives us a 1, and we add them up. We have our answer for fib, or we have an answer for 3 in our function called 3. Okay, so
Mm-hmm.
it's gonna be 2, then it's gonna move up, then it's gonna go in 4. Now 4 is gonna have our answer of 3, which is 2, and it's gonna call another fib, which is fib2, right?
Yeah.
Fib2, it's gonna call a fib2, it's gonna go 2, and that 2 is gonna call a fib1 and a fib0, right?
Right.
So that is gonna be like 1 plus 0, it's a 1, it's a 0, plus it's a 1, so it has a value of 1, and it returns fib2's value, it's gonna be a 1, and over here the fib value of fib3 is a 2, right? A 2 plus 1 is 3, so fib4 is the value of 3. Okay, so fib4 returns the value of 3, and now fib5 comes into play. Fib5 gets a 3, right? Fib3 is still left.
Yeah.
Okay, and these have to get added up. So fib3 goes over there, and it kind of calls 2, and then it calls 1. 1 gets resolved into 1, of course. Okay, fib1, and fib2 gets resolved into fib1 plus fib0. We've discussed it already. So that gives us a 1 plus a 0. So that gives us a 1 for fib2, and that 1 gets over here, it's a plus with a 1, and then fib3 returns us a 2, right? Okay,
Yeah.
so it's a 2 over here, it's a 2 plus 1, it's a 3 plus 2, sorry, not a 2 plus 1, it's a 3 plus 2, it starts at a 5. So that's how trees are working over here. Since we have two recursion calls, we have two basically branches, you get it?
Yeah.
And those lead to our final values. Now let me just check this one thing. 1 plus 2 plus 3 plus 4 plus 5. Okay, I'm just gonna show you one fun thing. This is gonna be fun. The leaf nodes. What are the values of the leaf nodes? Can you check the values of the leaf nodes? Do you know what are leaf nodes?
Yes. Yes. Yes.
So they don't have any other children. Okay, they don't have
Yeah.
anything branching down from themselves. So we have a fib
Uh,
1, a fib 0, a fib 1, fib 1, fib 0, fib 1, fib 0, right? This is not something I've
yeah.
even talked about in my video. Add them all up.
Right.
What's the answer? Add all the fib 1s and the fib 0s up.
Right.
There's a fib 1, plus there's a fib 0, plus there is a fib 1, this one, okay?
Right.
Okay, plus there is a fib 1, this one, plus there is a fib 0, this one, plus there is a fib 1, this one. Oh shoot.
Mm.
I'm just gonna write it over here. Okay. Plus a fib 1, and then there's this one, plus a fib 0. Wait a second, I'm missing a fib. The one, 1, 2, 3, 4. Yeah, this is a fib. Sorry, this is a fib. This is a fib 0. So this is a fib 0 right over here. This set resolves into a 0, and this is a fib 1. The last one, this one. So all the leaf nodes, they give us a value of this resolved into, what does it resolve into? Yeah,
Fib 1 plus fib 0 plus fib 1. So 1 plus 1 is 1. 0. Sorry, it's 2. And then 0 remains 0. So it would be 4.
something, somewhat of a mistake I made. Like it's 1, 2, 3. No, no, there's no mistake. Yeah.
Okay.
Okay, so the leaf nodes tell you the final answer as well. You get it?
Are they all combined or are they separate?
What?
Are they all combined like the Fibonacci calls you made? Are they combined like fib one in both lines,
All
or
the
are
all the
they separate?
all the things actually kind of end up at fib 1 or fib 0. Fib 0 contributes nothing and fib 1 contributes a 1. Okay,
Okay.
so the leaf nodes are actually what kind of help us give us the final value. So that's something you should know.
Yeah.
It's actually the fib ones which are doing all the grunt work. It's just
Right.
upper management, like even in a company. This is how it works. There's an upper
Mm-hmm.
management, and that upper management is like uh it gets all the credit, it gets all the things, but it's
Yeah.
actually the low ones who are actually doing the work, the interns.
Right.
You get it? Okay.
Yeah. Yeah.
The upper ones just manage the interns.
Right.
You get it?
Yeah, I know.
Yeah, that's how it's working, and it kind of adds up to 5 over here.
2, 2 plus 2 is 4, 4 plus 0, 5. Wouldn't it be 6?
How?
Or is it 5? Oh, um,
Bad handwriting, maybe?
one of them looks like a number 2 actually. Yeah.
Where?
1 plus 0 plus 1 plus 1. That one.
Which
Yeah,
one?
this one, this one.
This one? This one looks like a
Yeah.
2?
Oh, no, the one above it.
This one?
Above it, above it.
Above it? Oh, this one?
Yes, yes.
It's a 1. It can only be a 1 or a 0 since we only have cases for 1 and zeros.
Right, right, yes. Yeah, it's a 5. Yeah.